Welcome back, Math 20 or 30-2. Today we're looking at sinusoidal functions and polynomial functions lesson 3. And that's just modeling data using the polynomial function. So this one here is fairly straightforward. We're just going to be using our graphing calculator here for polynomials. We're still not quite yet into sinusoidal. We're just looking at polynomial functions. So here's the first one here. It says plot the data above and say what kind of regression it is. So just looking at this, we want to see what it is. So we already looked at what is a constant, linear, quadratic, and cubic. So you guys can start this one here by yourself, and I'm already going to start on the next question. Right here, it tells you how to use the regressions and type it into your calculator. The next little steps here is just telling you how to put it into your calculator, which is very nice and handy. I do suggest you end up reading those over. So here we go. Question number 1 for us. It says, concentration in milligrams per liter of medicine of a patient's blood is measured as time passes. Susan has collected the following data and is attempting to express the concentration as a polynomial function of time. So here we're going to look at this here. Okay? Now, let's put all these into my stat list, edit, and I'm going to put all these in. So I had something in here already, so I'm going to clear both lists and start editing it in. So what do we have? I'm just going to move this over so I can see everything. We start with, this is my x at the top, 0, enter, 1.5, 3, 4.5, 6, 7.5, and 9. Okay, now we're going to go over. And we're going to get 0, enter, 26.9, 41.2, 47.8, and 46, 36.8, and 20.3. Whoops, 20.3. Okay, so now I'm going to put this all on, so clear that. And we're going to put that all into my graph. So I put on my stat plot, but I first have to make my window work. So my x, we don't go below 0, but we go all the way to 9. So I'm going to go from 0 to 10, just to see everything. Okay? Now let's take a look at my y. We go from 0, and then what's my max? 47.8. So I'm going to say my y, I'm going to go a bit below. I'm going to go -5, just so I can see a bit below it. 5, and I'm going to say my max is going to be 50. So I could just have a little bit of a view. So here we go. I look at this, and what kind of function is that? Just by looking at this graph, I know automatically that that there is a frown face, so it must be a quadratic, and a negative quadratic. Look at that. I already know so much, and I have barely even done it. So it says right here to use this. It's telling us it's a quadratic and put everything A, B, and C to 2 decimal places and use the line that fits the data best. So we have to use the regression. But they didn't have to tell us that it was a quadratic because it was a frown. We knew automatically right away that it was a quadratic. So let's go into here and we want to calculate, and it's a quadratic regression. This one, x, y, enter. Okay, so my formula looks like this. I'm going to have -1.86 t squared plus my b is 18.76 t, and that was rounded down 4, this one rounded up because it'd be 8, and we're going to have plus 1.21, and that is c is equal to all of that. So that's my formula. Okay, now on the graphing calculator, graph the regression equation and the scatter plot. So we want to graph the regression equation. You might remember this also from the unit before when we graphed logarithmic and exponential regressions. So how did I do that? I go, you want to look at my distribution, variables, statistics, equation, and we did some kind of regression, and I graph. There's my beautiful graph. Look how well it matches up. It works perfect. Now, it says here, there are, I'll move it over so we can read it better. There are domain restrictions on the function. So my domain restrictions is Well, obviously,
Welcome back, Math
that's
20
or
30-2.
Today we're looking at
and we're going
only up
functions.
to 9 hours.
Applying
only
functions
going
less than
10
3.
to 9 hours.
That's just modeling data.
Right? Then it
using
says
polynomial function.
there are domain restrictions
So
on
this one
quadratic
here,
graph. The
it's
minimum
fairly
value
straightforward.
is 0.
We're
And
just
the
going to
maximum
be
value
using
for time
our
is
graphing
the
calculator here
intercept.
for
Here I said 9,
polynomials.
but if I
We're still
look
not
at
quite
this,
yet
the
into
maximum time,
science,
we're just looking
at polynomial.
So I can't quite see
So here's
it.
the
I'm
first
going to
one
change my
here.
window. It says plot the data
And I'm
above
going to say
and say
maybe
what kind of
regression
x.
x.
So just looking at this, we want to see
it
what it
gets-
is. So we already
so
looked
this
at
is
what is a constant
range
linear
between
quadratic
0
and 0. So you guys can
whatever
start
that
this
value
one here by yourself. And I'm
Okay.
already going to start on the
So,
next question.
Right
Now
here,
it says
tells you how to
determine the
regressions
domain
and
of this
type
model.
into your
So to
calculator.
determine the
next
domain,
little steps
I
here,
know
it's just telling you
x
how to
must
put
be
it
greater
into
than or
your
equal to
calculator, which is
0.
very nice.
But it also
I
must
do
be
suggest you
less
end
than
up
reading
this
this
value
value
there.
there.
So
So here we go. Question number 1 for us.
I have
it
to
says
calculate
the 0. So we want
concentration in
anywhere left of
milligrams
it.
per
left.
liter of
And
medicine
right,
of the
anywhere
patient's
right
blood
of
is
it.
measured as
Okay,
to
that's
analysis.
And then my
Susan
guess-
has collected the following data
That's
and is attempting to express
I end up getting
concentration
10.1
as a polynomial function.
So 10.16.
So
So
here
here
we're
we're
going
going
to
to
look
look
at this
10.16. Now,
That's interesting.
let's put all these.
So
into
that
my
is
sample
how
list.
much blood it's
Edit.
between. Or
I'm going to
sorry,
put all
that's-
these in. So
tells
I have
us
something
how
in
much
the right,
medication is
so
in
I'm
the blood.
gonna
Or
put
time is from here.
start here.
editing it in.
because after that it resets.
So what do we have?
So now here we
So
go.
we're
It says
see
the
everything?
doctor
has decided
We start
that the
with
patient
this is my
needs a
x at the
second
top,
dose of
0
medication
enter,
when the concentration of the blood
3
is less than 10 milligrams
5
per liter.
6 7.5.
First dose of medication was
and
given at 9 a.m.
Okay,
So this is, we know the start.
Over,
That's time
and
0.
then get
So
0,
time 0 right here is 9 a.m. We want to figure out when this is,
47.8
or when it's at 10.
46
Because it says at 10
36.
milligrams. Once it gets below 10, what do they do?
and 20.3.
They jack it back up.
Oops.
Let's take a look at this here. So my y2 is
So
10.
now I'm
Why
going
did I
to
say that's
put this
10?
all on.
Because that's,
Hear
we
that?
want to know,
And
and
we're
this
going to put
equation
that all
equal
into my
10,
graph. So I put on my stat.
that is
plot.
when
I first
we
have to
make my window work, re-inject.
So my x,
So 10
we don't
is
go
equal to
below
that.
0.
We want to know when it's equal to
But we
10.
go all the way
Concentration
to
to
10.
9.
So I'm going to
have
go
to
from 0,
calculate my intercept, just to see it.
so I goes,
Okay, calculate. Now let's take a look at my
intersect.
y.
So
Curve
from
1,
0.
first curve. And then what's my
I'm
max?
going,
It's around there.
so I'm going to say my y.
I get
I'm gonna go a bit
9.6.
below. I'm going to
So
go
we get
9 just so I can see
9.6 hours.
5. And I'm going to
Alright.
say my max is.
So 9.6 hours is when
So I
it'll
could
be
just have a little bit of
9.6
a
hours
view.
from there.
So here we
Well,
go. I look at this.
If I
What
go
kind of function is that?
9
Just by
hours
looking at
plus
this graph.
3, that
I
gives
know
me
automatically that
12
that there
hours.
is
a
a
12 o'clock. Then I
round
plus another
face,
6
so it
hours.
must be
That's
a
total of
quadratic
9
and a
hours.
negative
Add
quadratic. Look at that. I
gives
already
me
know so
6
much.
o'clock.
And I also need barely even done it.
6
So it says
hours.
right here to use this.
It's telling us it's a quadratic
So there
and put everything A, B, and C to
0.6.
2 decimal
So I'm
places.
going to go
and use the
0.6
line
hours
that
there's
this
60
the
minutes.
data
And
best.
that's
We have
a
to
whole
use
hour, and I wanna
regression.
times that by
They didn't have to
0.6,
tell
which
us
gives
that
me
it was a
total
quadratic
of
because it was a frown. We knew
36.
out of way, automatically, right away, that it was a
6 hours.
quadratic. So let's go into
Oops,
here,
that doesn't
and we
equal
want
6.
to calculate,
What am I
and
doing?
it's a quadratic
That is
regression.
equal to
It's
6
1
o'clock.
x, y,
and
6 something. Okay.
Well,
So my formula
6,
looks like
and
this.
then we have 36
I'm going to
minutes.
have negative 1.86
And that was AM, so this is going to be PM. It's in the afternoon. And that's how we solve
t
that.
squared plus
Okay.
my b is
If you have any questions, please don't be afraid.
18.76 t, and that was rounded down before. It was rounded up. It's the 8. And we
Last
one plus 1.
We have a
research student, and that is that you see it. A research student was
That-
investigating
that's my
the relationship between job satisfactory.
Now on
J
the
and
graphic
measured
calculator,
by
graph
employee,
regression
from
equation
scale
and
of 1 to
scatter
10.
plot.
So job
So we
satisfactory
want to
goes
graph
from
the
1 to
regression
10.
equation.
Okay?
You might remember
And
this also
the
from
productivity measured by
Uniform
employment
scale
we graph
to 100.
logarithmic and exponential
So
job
regression.
satisfaction is on the
So
bottom.
how did I do
10.
that?
This is my x.
Hello.
This is my
Now
y.
look at my distribution.
So
Oh, sorry.
these
I
variables.
already know my window.
But first we're going to
Statistics
put all this into equation,
plus
and we
stats.
did some kind of regression.
Stat bar. So I'm just
And I graph this over. So you can see it.
there's my
Okay, so I'm
Look
going to
how
put
well it
stat.
matches up.
Edit. It works. I have to clear my list.
Now,
Remember, do not delete. It says here,
there are. Oh, I'll move it over. So
okay,
better.
so I
there
start
are
3,
domain restrictions
8,
on
7,
the function.
5,
So my domain
9,
restrictions is
6,
well, obviously
6,
time less than 0.
10,
Negative time.
8,
And we're
2,
going only up to
5,
9 hours.
7.
So only going from 10 to 9 hours.
Okay, hopefully I
Alright?
didn't make a mistake.
Then it
We'll check
says
soon. 44,
there are domain restrictions on the
21,
quadratic graph. The
75,
minimum value is
6,
0, and the maximum value
90,
of time is the
70,
intercept.
71,
Well,
98,
here I said 9, but if I look at
98,
the maximum time
75,
to there. So I can't quite see that, so I'm going to change my
68,
window.
and 77.
And
Good.
I have the same amount in each, so I'm pretty sure I'm right. So now, when I look at my window, my x, yes, it is
hits.
only between
So
1
this
and 10.
is my range.
So I'm going to say 0
to 12.
and whatever that value.
So I just want to go
Okay.
a little bit between it.
So my domain is, now it says,
X has to
determine
be
the domain
between
for this model. So to
1
determine the domain,
and
I know
That's
x
it.
must be greater than or equal to 0,
Oh,
but it also must
scale.
be
Oops.
less than or equal to this value.
So this
there.
is my
how do I find that value?
domain.
I have
Okay.
to calculate
Let's take a
the
look at
0.
my range.
My range
We want
is
left
between
down.
1
That's
and
anywhere
100.
left of it.
Range,
That's
Y,
left. Then right. Anywhere right of it.
Okay, that's
1
right.
and 100.
And my guess.
That's a 1.
So I
That's
graph
close.
this.
Oh, sorry. I'm
I
going to
end
count
up
by
getting
2s there.
10.15.
So
Nine. So
and
10.16.
So I'm going to have 0.
So it must be less than
And here I'm going to put 100.
6.
And 10.
That's interesting.
Oh.
So that is how much blood
Just so I
is
can see
between.
it. Or,
And I'm going to count
that's-
this one by 10. Tells us how much medication
so I
is in
have
blood.
to-
Or
Okay.
time.
So
It's from here to here.
Because
after
after
that,
that, here are my
6.
graphs.
So now here we go. It
Stat
says
plots
the
covered.
doctor has
There we go.
decided
I got
that
the same thing
patient
they get
needs a
here.
second dose of
Okay.
medication.
So the student looked at the
Concentration
scatter
is
plot.
less than 10
student A
milligrams per liter.
and
So we have the same scatter plot.
First dose of
They
medication
thought
given
it
at
was
9
a
a.m.
linear.
So this
They
is, we
thought
know
maybe
the
it
structure.
was
That's
a linear
time
equation,
0.
something
So
like that.
time 0,
So let's
right
do this
here
linear
is
regression.
9 a.m.
Put everything in 2 decimals.
We want to figure out when this is.
And then I'm gonna quit. And then I'm
Or
gonna
when it's at
stop.
10.
Linear
Regression.
Because it says at 10 milligrams. Once it gets below 10, what do they do?
And they think it's a linear.
They jack it back
It's like
up.
a straight line. There's just some
Let's
outliers.
take a look at this
So it
here.
makes a general
So
straight
my
line.
y2
Which
is 10.
makes sense.
Why did I say that's 10?
Now,
Because
they
that's-
get,
we want to know,
in this
in
case,
this equation
we
is
get
equal to 10.
T is equal
That
to
is when we have to
7.91
reject. So 10 is equal to that. We want to know when it's equal to 10.
1.91
is
J.
10. So I have to calculate
plus
my intersect.
Well, my B value is
So
19.
those-
Calculate. Intersect. So curve 1, first curve. I'm going,
Okay.
now it's around there. Enter, enter,
When
enter.
I put this,
I get
into my graph,
9.6.
ooh,
So we get 9.
so I'm going to put that in.
9.6 hours. That. All right. So 9.6 hours
here.
is when it'll be at 10.
9.6
Oh,
hours.
so one for that one.
Well,
Enter.
if I go
9
So I
hours.
look at
plus
that.
3.
That's pretty
That
good.
gives me
It's not the most accurate.
12
is it?
hours at 12 o'clock. Then I
Okay,
plus
so that's
another
what that one-
6
now,
hours.
the other
That's a
student
total of
says, well,
9
he
hours
thinks it's a
added.
cubic. Why?
Because
Because he
he
thinks
thinks
it
it
looks
looks like
but also need
there's a
0.6
point of
hours.
Okay.
0.6 hours.
So let's see if
Okay.
he's right.
So there are
Do that.
0.6.
So I'm going
In
to
this
go
case, when
0.6
we calculate
hours
it, he
is
thinks
60
cubic
minutes.
fractions.
And that's a
Okay.
whole hour. And I want to times that by 0.6, which gives me a total of. So you could push this all in.
36.
What they say for each
Oh,
one.
I'll
We
put
have it
that
on the
in. So
calculator.
6 hours.
You can put that all in.
And then
That's-
I'm just
this
going to
is
graph
60.
it.
Because not.
So let's
What
see
am I
here.
doing? I'm going to get is equal to 6 o'clock.
Go to
6 something.
Well,
Very
6, and then we have 36
Equation.
minutes.
Let's see if this one works.
And that was AM, so this is
Oh,
going to
look
be
at
PM.
that.
It's in the afternoon.
That's pretty
And
good.
that's how we
That looks like it
that.
matches fairly well, doesn't it?
If you have any questions with
Then
this,
it says, which model do you think best represents the
how I did
the
this.
data? In this case, I'm going to say a cubic. Okay, last one, because of the point of inflection. We have a research student. Let you see it. A research student was investigating the relationship between job satisfactory,
Okay.
J,
So they're both
and
kind
measured
of
by
right.
employee
Person B was a
from
lot
scale
more
1
right
to 10.
than-
So
so
job
it's
satisfactory
so cubic
goes from
because of
1
the
to 10.
inflection.
Okay? And
So I
the
hope you
productivity
understood this lesson.
measured by employee on a scale of 1 to 100.
As I see you tomorrow.
So job satisfactory is on the bottom, 1 to 10. This is my X. This is my Y. That makes my window so easy. I already know my window. But first we're going to put all of this into my stats. Into my stat bar. So I'm just going to move this over so you can see it. Okay, so I'm going to go stat, edit. I have to clear my list. Remember, do not delete, clear.
Okay, so I start 3, 8, 7, 5, 9, 6, 6, whoops, 10, 8, 2, 5, 7. Okay, hopefully I didn't make a mistake there. We'll check soon. 44, 81, 75, 66, 90, 70, 71, 98, 98, 75, 25, 68, and 77. Good. I have the same amount in each, so I'm pretty sure I'm right. So now, when I look at my window, my x is only between 1 and 10. So I'm going to say 0 to 12, because I just want to go a little bit between it. So my domain is x has to be between 1 and 10. That's it. So I have 11. That wasn't even on the scale. Oops, I'll show you what I wrote. So this is my domain. Okay? Now let's take a look at my range. My range is between 1 and 100. So my range, y, is in between 1 and 100. That's a 1 now. So I graph this. Oh, sorry. I'm going to count by 2's there. No, I'm going to count by 1's. So I'm indecisive here. So I'm going to have 0. And here I'm going to put 100. And 10. Whoa. Just so I could see everything. And I'm going to count this one by 10's. Just so I have 10. Okay? So, y equals, here are my graphs. My stat plot's covered. There we go. I got the same thing they get here. Okay? So the student looked at the scatter plot, student A, and so we have the same scatter plot, and they thought it was a linear. So they thought maybe it was a linear equation, something like that. So let's do this linear regression and put everything in 2 decimal places. So I'm going to go, and I'm going to quit, and I'm going to stat. Let's find my linear regression. Calculate, and they think it's a linear. It's like a straight line. There's just some outliers, so it makes it generally a straight line, which makes sense. Whoops. Now they get, in this case, we get P is equal to 7.91 J plus, well, my B value is 19.89. That's a J, by the way. Okay? Now, when I put this into my graph, y equals, so I'm going to put that in, so I'm going to go, we're looking at stat, whoops, we're going here, I'm always hitting the wrong one for that one, enter, enter, graph. So I look at that, that's pretty good, but it's not the most accurate, is it? No. Okay, so that's what that one is. Now, the other student says, well, he thinks it's a cubic. Why? Because he thinks it looks like there's a point of inflection there. Okay, so let's see if he's right. So clear that, and in this case, we're going to calculate, and he thinks it's a cubic regression. So push enter. And let's put everything they say. So you could push this all in, what they say for each one. We have it on the calculator here. You can put that all in. And then I'm just going to graph it though. So let's see here. I'm going to get, go to variables, equation. Let's see how this one works. Oh, look at that. That looks pretty good. That looks like it matches fairly well, doesn't it? Huh. So then it says, which model do you think best represents the data? In this case, I'm going to say a cubic, because of the point of inflection. Okay, so they're both kind of right, but person B was a lot more right than person A. So cubic because of the point of inflection. All right, so I hope you understood this lesson. As I see you tomorrow, if you have any questions, don't be afraid to ask.